Noticing a slight drop off in attendance since I've started recording, which I told you may happen. Seems like this section over here has gotten thin. Yeah, you said it, not me. All right, so I have kind of a change of plans on what we're going to do over the next couple of days. We have Thanksgiving holiday coming up, right? So today, right, Tuesday, we have class, of course. And then Thursday of this week, we have class, right, today and Thursday. And then next Tuesday, we have class. And then next Thursday, that's Thanksgiving, no class, right? So here's what I have planned. We are due for an exam, all right? We are due for an exam. So what I'm going to do today is I have a review, okay? So we're not going to cover any new material. I'm going to go through this review with you today, all right? And actually, I'm going to give you this review. I'm going to go over problems similar to this. That way you have something you can take home and practice, all right? So today, I'm going to review. Can't spell review today, apparently. Review, all right. And then Thursday, I'm going to do something you probably have never had happen in a class before. What we're going to do on Thursday is we're going to actually do what I call a risk-free exam. All right? So you will come in on Thursday and you will take an exam, all right? You're going to work on your own, and so the way it's going to work is you take the test, and it's like really a practice test, unless it goes well for you. Then you can use that as your grade. Does that make sense? If you do poorly on it, then shouldn't have said anything. There's no harm in it, right? This is going to have no impact on your grade. However, on Tuesday, we will take the exam. So if you come in on Thursday, you sit down, you take that risk-free test, right? That risk-free exam. I will look at it, I will grade it. If you're happy with that grade, then you don't have to be here on Tuesday, all right? You don't have to be here. You can just take that as your grade. But if on Thursday you come in, it doesn't go so well, or you're just not quite there yet, and you haven't had enough time to review everything, then you come in on Tuesday, and then that grade will be your grade. Is that clear to everybody? Mm-hmm. Yes?
What if you take the risk-free thing and you did good, but you still want to come in for Tuesday so you do worse?
You choose. Oh, okay, yeah. So if you come in on Thursday and you take it, let's say you get an 80, right? You're like, yeah, that's pretty good, but maybe I can do better. You come in on Tuesday and then you get a 60. I'll take the 80. I'll take the higher of the two. All right? Does that make sense? Now, Thursday is going to be a little tricky because there will be some people here on Thursday that are like, look, absolutely, I am not ready for this test. And because there will be other people testing in the room, I can't sit here and go through problems. So for those people who on Thursday know this is just practice for me, we might have to actually relocate to the room across the hall so that I can help and just kind of float back and forth between the two rooms. Does that make sense? That way if you're like, yeah, for sure, I'm not ready for the test, but I still need some help with this, I can help those students, and then those who are just really testing can sit here and test. Yes?
With the risk-free, can we still have our notes?
Yeah, you can still have your reference sheet.
Yeah.
Not like notes, but you can do a reference sheet, yeah. Yeah, so we treat it just like the other exams. Okay? How does that sound to everybody? So that means there's no new material at all until after Thanksgiving. Okay, well that's the plan then. So you're probably curious to see what's going to be on this test, yes? Here it is. So I'm going to pass this around, grab one, pass the rest around.
Thank you.
Uh-huh. That's for me. Go ahead and make sure these get that way. Thank you. Hello. make sure you talk to me at the end because that was kind of important, right? Yeah, so just, talk to me before you leave about what we're doing. Yeah, they're different exams. Yes, they are different exams. Yes. All right. So everybody have a copy? Let's first talk about each problem topic-wise, what it is, and then we'll go through. So problem number 1, this is rational functions. Now, on rational functions, that was the one that we did not have on our last test, and you were like, thank goodness, we don't have that on this test. Now it's here. That's the one where you have to figure out the x-intercepts, the vertical asymptotes, the horizontal asymptotes, the test points. Remember all that? All that stuff? It's a lot involved in that problem. Okay, number 1. Number 2, so I'll put a little sad face next to this because that's not a very easy problem. Number 2, we have exponential functions. And for exponential, this was actually pretty easy because this is where we made a t-table and we were just going to plug numbers in and use our calculator. Does that ring a bell to you? Yes? So that problem is actually pretty easy. We're going to go through this. I just want to talk about what are the topics on the test. For 3, okay, this is our simple interest. This is where we're going to use our formula A equals P e to the RT. And for that, for problem number 3, it's very straightforward because I give you the amount of money that you put in, I give you the interest rate, I give you the time. So you're just going to use your calculator and get an answer. So that one, I think, is pretty easy as well. Number 4, we're still going to use this formula, but this was a problem where you actually had, let me circle on here. On number 3, you have to solve for A. So it's pretty easy to solve for A if I give you all this. You just plug everything in. But for number 4, you have to solve for time. And that's where we had to bring in that logarithm idea and stuff, right? The log thing. So that's a little bit harder. I'm not going to say it's a sad face, but it's definitely, just kind of eh. Then we get to number 5 and number 6. Number 5 and 6, those are both systems of equations. So you can use substitution, or you could use elimination. And remember, I think you'll prefer the elimination. Last class, I think most of you said you like the elimination method more. And so that's 5 and 6. And number 7 is the mixture problem, right? Which I sent you home with a couple of those to practice. And that's it. That's what's on the exam. All right? So what I'm going to do now is I'm not going to work through this. This is a thing for you to take home and practice. I'm not going to provide the answers to this. All right? This is really just for you to have. All right? So I'm going to go through right now, and I'm going to do 7 problems, and I'm going to just make them up, and they're going to be similar to these. Then you go home and practice. Then you come on Thursday, and I'll hand out a test, and you can either take that test for the grade, or you can say, I'm just going to practice. Yes?
Will you release the answers so I know how to
To what?
for the review?
Well, that's what I just said. I'm not going to release the answers for this, for the review. I'm not. Now, if you want to check with me on a particular problem, that's okay. But I'll try to. I just can't promise you that I will get that in time before Thursday. Right? I'll try and get you the answers, but no promises. But if you have a question like, did I do this right, just reach out to me. All right? All right, here we go. Let's see if we can finish this whole thing in the time we have. All right? Oh, you're also allowed to have a reference sheet. I think that's pretty much been standard, right? 1 sheet of paper, front and back, formulas, steps, procedures, but no worked out problems.
Will there ever be a time where you tell us the work?
No, you can have it. You're good. All right, so for this one, we want to sketch the following rational function. And so I'm going to make one up similar to this one. Let's do, I don't know how bad we want to go here. Let's go 4x squared minus 20x over x squared. Hold on. There we go. Sketch the function. So let's see if we can go back to the archives of our memory here and what we have in our notes on how we go about this. The very first step to sketch this is to do what? Anyone have it written down? Factor, right? We factor the numerator and denominator. Numerator and denominator. Good. So to do that, let's start with the numerator. When I take the numerator and I go to factor it, we do the first step of factoring anything is GCF. Do we have a greatest common factor? Do we have something common to both of those things? Yes, we have a 4, right, in both, and we also have an x. So I can pull out a 4x, and I will be left with what here when I pull a 4? X minus 5. X minus 5. Because when you multiply 4x through to here, you get 4x squared, and then 4x times negative 5 is negative 20x. So they both had a 4, and they both had an x. So that's why I put 4x out here. Is that all right? GCF? We're done with the factoring of the top. Now we need to factor the denominator. So x squared plus 4x minus 21. Now, there are like 5 different ways to factor this depending on you, right? I've told you this since the beginning. First, we look for GCF. There's not a greatest common factor, right? They do not all have x's. And there's not a number that goes into all of these. And I remember I talked to you, like if you know how to factor this, do it, right? Do it. But if you don't, I gave you all a method of doing this. And the method I gave you required we do that synthetic division. Remember that thing? Okay. So I'm going to do synthetic division over here. And I'm going to use the numbers 1, 4, and negative 21 inside the division box. And then I'm going to use some other numbers to try and see if I can do synthetic division and get a 0 here. So I have to create that list of numbers. And you remember how we create the list?
21.
You take the number 21, you write down all the factors of 21. So all the numbers that divide into that evenly. Plus or minus 1, what else divides in there? 3, what else? 7, 21, right? Those are the only numbers? Like 1 times 21, 3 times 7, there's nothing else. So I told you to start with 1, right? Okay, start with 1, see if it works. Drop your 1 down, 1 times 1, 1. Add down 5. That's not working, right? That's not working. We need this last number to be a 0, and it's not. So I go to the next number, I try again. Negative 1. So 1 comes down. Negative 1 this time. Positive 3. Negative 3. This doesn't work either, right? Okay, nope. Okay, we keep going. Anyone have a question on what I'm doing? Does it at least seem familiar to you? Like we've done this? Yeah? Okay, try 3 now. 3. Let's see, drop your 1. 3 times 1 is 3. I think this is going to work. 4 and 3 added up is 7. 3 times 7, 21. There we go. We got a 0 here, right? That's what we wanted. Now the question is, how do you interpret this little whatever, chart, table, however you want to look at it? How do we get to the answer from this? Take this number, and we create one of the factors, which would be, remember, the opposite, right? X minus 3. And then the rest of it comes from these two numbers, starting with 7 here, and then plus, because it's positive 7, and this is the number in front of x. There we go. So that is the factored form of the denominator. X minus 3 times x plus 7. So what I'll do is I'll come back over here to my original function. I'm going to write it, again, factored. On the bottom, x minus 3 times x plus 7. There we go. Step 1 is done. I've completely factored the top and the bottom separately. Any questions? What's step 2? Find the x-intercepts. So step 2, we find the x-intercepts, and to do that, what did you say? We set the what? Numerator equal to 0 and solve. So I take the numerator, which is the top, right? I set it equal to 0. So I take 4x times x minus 5. I set that equal to 0. And since it's already factored, that means I just set each factor equal to 0. Okay, what's the only number you can multiply times 4 to get 0? 0, right? 4 times 0 is 0. That's the only way to do it. And then over here, you just add 5 to both sides, you get x is 5. We have 2 x-intercepts, right? 2 x-intercepts. These are dots. These are actual points on our graph. Any questions on that? Third step, verticals. To find the vertical asymptotes, we set the denominator equal to 0, right?
Yeah.
So we take the x minus 3 times the x plus 7, we set that equal to 0. That means we can set each of those factors equal to 0. You should get 2 answers, 3 and negative 7. These are not points on our graph, right? Those are not points. Those are those vertical barriers, right? Those vertical dotted lines. Step 4. Horizontal asymptotes. Okay, to find the horizontal asymptote, actually there's only ever going to be one. If there is one, there's only going to ever be one. And to do that, this was where we had the 3 different cases. Are you saying case 2? Oh, I did. Oh, I never gave you that last one. That's right. I'm sorry. There are 3, but we only did 2. Thank you. So what we have here is we look at the degree of the numerator, right? Degree of the numerator and the degree of the denominator, and we compare them. What's the degree of the numerator? So what's the highest power of x that you see in the numerator? 2. So the degree is 2. And the degree of the denominator is also 2. And that means they're the same, aren't they? They're the same. And this was this, when we have that the 2 degrees are the same, right? These 2 numbers are the same. In this particular case, this is where we do have a horizontal asymptote. It'll be y equals, and anyone remember what it is? The leading coefficient of the numerator, this number right here, divided by the denominator's leading coefficient, which is a 1. You take those 2 numbers, you make a fraction out of them, 4 over 1, but 4 over 1 is just 4. So this is our horizontal asymptote. Good. What was the other case? They're either the same power, or the only other thing I ever showed you was when this is smaller than this, right? Yeah. So let's say this was a 2 and this was a 3 on the bottom. Then what would be your horizontal? The what? Where would your horizontal be? If let's say this was
0.
Let's say this was a 2 and this was a 3, or this was a 2 and that was a 4. Then that would be the x-axis, or y equals 0 would be your horizontal. Look in your notes. That was the other case. So look, at this point, we're going to go to the next step. But just to remind everyone, these are points, right? X-intercepts. These are points on our graph, right? These are the vertical dotted barriers, right? And then this, y equals 4, is a horizontal line that we only draw at the ends, and that's the magnet that pulls our graph towards it at the edges. Yes?
What if it's like 4 and 2?
If it's the other way, like 4 here and 2 here, that's the other case I didn't cover in here. I decided I'm only going to give you, you don't have to worry about that. Yeah. All right, so what's the next step?
Test points.
I'm going to get test points, but I have to do something before that. Sketch it, right? Let's put all this information onto a picture, right? Let's actually see what this all looks like. All right, I'm going to start with my x-intercepts. I'm going to use colors. This is going to be fun. All right, let's do our x-intercepts. 0 and 5. So 0, I have an x-intercept. 1, 2, 3, 4, 5. At 5, I have an x-intercept. Those are points on my graph. Then I have my vertical asymptote. I have 2 of them, don't I? Yeah. At 3, 1, 2, 3, here's 3. I draw a vertical dotted barrier. I do not draw a point here, right? Don't screw yourself up and draw a point. Just draw the vertical barrier. And then also way over at -7. I'll just put -7 back here. Vertical barrier like that. Then I have my horizontal asymptote, y equals 4. Remember, draw it at the edge only, right? At the edge only. So y equals 4, I go up 4. 1, 2, 3, there's 4. And instead of drawing it all the way across, I just go out to the edge, put a dotted line this way, and then over here, somewhere like that. And just remember, that's where my graph will get pulled to at the edges. So to answer, not your question, but a similar question, if this was a 2 and this was a 4, then what would happen is this wouldn't be this would just be the x-axis. So my dotted line would not be up here. Where would it be? Right here. There and there. Okay? That's where it would be. Damn. I've missed a lot more than I've made. Assist. Okay, now test points. All right, now the test points. Do you remember how you can tell how many you're going to have?
You have to look at your x-intercept and your vertical.
Count how many of these you have? 2. Count how many of those you have? 2. And it's 1 extra, so 5. We should have 5 test points. And those test points, I'm going to make sure that I pick them so that I have information about what's happening in between and on the edges. So let's start over here. We don't know anything that's happening over here, so I'm going to pick something over here. Don't put a dot. I like to put an X, right? -8. Something between here and here. Anything you want. -5. Something between here and here. 2. Ooh, okay, there's really only one good choice between here and here, right? 4. Okay, that's 1, 2, 3, 4. I need one more. Over here, 6. Okay. Okay, so maybe it's closer, but that's not important. It's not important as long as it's to the right. So I have my 5 test points. Now, what do we do with these test points? Plug it in here. And all we care about is whether or not our answer is positive or negative. Because if it's positive, that means we're going to put a point above the x-axis. And if it's negative, below, right? Okay. So let's try that. Let's plug these in. And what I told you is that I think personally that it's easiest and it's fast if you use this. Okay? Let me try -8. If I take the function and I plug -8 into it, that means I replace this with -8. What's 4 times -8?
Negative.
It's some negative number, right? 4 times negative, that's a negative number. And then I'm going to multiply that times what is -8 take away 5? Still negative, right? 2 negatives on top. Over, okay, -8 take away 3 is -11, so that's still negative. And then -8 plus 7, careful, -8 plus 7 is still -1. So I have a total of 4 negatives there. The two negatives on top become plus, two negatives on bottom is plus, and a plus over a plus is plus. So it's a positive value. When I plug in -8, I know I get a positive number, so I put that dot here. Could I put it up here? Yes, totally up to me. Totally up to you, all right? Don't let this dotted line over here dictate where you put that point. Just put a point above and you're in business. I have some good news. I'm going to save you time. And I'm going to promise you on the test that they will switch, okay? They will switch. You don't have to check them all. That sound fun? Okay, but you better double check the first one you get, because if you miss the first one, that's wrong, then everything else is going to be wrong, okay? So what I'm getting at is if you do -5 right now, it will be negative. If you do 2, it will be positive. If you do 4, it will be negative. If you do 6, it will be positive. Now, if you're one of those people like, I don't trust him, you can check each one, okay?
So it's gonna be like that.
Well, I'm not saying it's going to be positive, negative, positive, negative, positive. It might be negative, positive, negative, positive, but it will switch. Yes, it will switch. You're welcome.
Thank you.
But I'm saying if you don't trust me, just check them. But then that'd be kind of mean of me, huh? So at -5, I'm going to put a dot below. And then at 2, it's above. And then at 4, it's below. And at 6, it's above. The reason I'm doing that is because I want you all to focus more on getting the graph right than getting these points in the right place. Because from looking at your work that y'all have turned in, it's the final graph that people are still having trouble with drawing. It's like you can get all the points, but then how do you graph it? So, all right. Any questions up to this point? I'm ready to put everything together now. All right, starting with the leftmost point, I just imagine what has to happen if I go this way. I see that thing, right? So I'm going to have to flatten out towards that. And then as I go to the right, I've got the barrier, right? And this barrier is going to have to force me up. I can't go down because I crossed the x-axis. Right? We're on the first problem still, right?
Yeah.
Okay, this is a long problem. We know that. So this to here, and then this is going to turn up and go like that. And I didn't mention this on the review, but I will mention this. This problem will be counted double. So like there's 7 problems on this review. This would have the weight of 2 problems. So all the other problems will be equally weighted, but this one will count double. So you want to make sure you get it right. Okay, now go to this one. Oh, I can move right to the next point, this one. To the left, there's my barrier. Can't go up, right? No x-intercepts up here, so it's got to go down. Then I'll connect straight to here, and then I'll connect to here, and then another barrier forces me up. So it's going to wind up looking nice and smooth like this. And then in here, you can kind of almost see what's going to happen, right? These 3 are going to connect. It's going to flatten out this way. And then this point, if I try and draw this way, the barrier forces me to go up or down, but I can't go up. So I have to go down. It kind of looks like it has to go down too, right? There it is. We're done. That took about 20 minutes or so. All right, now the rest, some of these are going to go really fast now. Okay, so you really want to take your time on this question because this is like, what, if there's a total of, there's a total of 7 problems, right? Then each problem is going to be worth more than 10 points, which means that if you miss this one, you already are letter grade wise, you can't get an A, right? If you mess it up. Of course, I give partial credit, so, you know, I'm just saying if like you just skip this problem, you're like already in C territory because it's worth the weight of 2. So it's like taking you down to like low 80s if you skip it. So don't skip it.
How many questions will be on the exam?
Around 7.
Okay.
Yeah, I'm gonna stay true to what I've done in the past with my reviews in this class, which is pretty consistent, right? My reviews have been very similar to what you see on the test. Okay, number 2, I'm asking you to sketch an exponential function. And the exponential function that I've given you here is f of x equals 1.45 to the x. And to do this problem correctly, all you need is a calculator. And not your phone, right? Not your phone. You have to use a calculator. So all I'm going to do is what I told you in class we're going to do for these. We're all going to make a t-table. X, this is going to be 1.45 raised to the x. We're all going to use the same numbers, -3, -2, -1, 0, 1, 2, and 3. All right, we've agreed on that we're all going to plug the same numbers in so that we all get the same answers. This should at least give us an idea of what's happening. Can anybody tell me right now, it's an exponential function, can anybody tell me whether or not that's exponential growth or decay? Do you remember what I told you to tell whether or not it grows as you move from left to right or if it goes down?
If the A is less than or greater than.
Yeah, it depends on this number. If it's bigger than 1, this is going to be growth. So we should expect a graph that goes like this. Okay, we know that already. The graph should go up as you move from left to right. The question is, what are the actual points? So on your calculator, what I'm going to do is I'm going to look at your table to see if you got the right answers. What I don't want is just for you to draw this and just be like, there it is, it's growth, right? I need to know some points. So on my calculator, I'm going to do 1.45 raised to the -3. This is 0.3, let's just round 2 decimal places. 0.33, yes. Now raise it to the -2. And I get something like 0.48 if I round it. And I don't really care about the rounding either. You could do 0.47 and I'd be okay. 1.45, raise that to -1. 0.69. And then when I do 0, I should get 1. When I do 1, I should do 1.45. 1.45 squared, you get about 2.10. And then 1.45 cubed, is about 3.05. Please make sure that you're getting those on your calculator because that will be what I look at when I grade this. I will be looking at this first, and then I will be making sure that your graph matches those. So here's the graph. We're not done, right? We have to graph this. So the way we'll graph this is we are all going to have 1, 2, 3, right? And -1, -2, -3. That will be the same for all of us, right? And now, depending on the problem, we got to know how far to go up and down. And you can tell by this.